Okay, so let's learn about how to use decorators in certain use cases which are quite predominant. One of them being checking arguments. So we have a use case for decorators, and the first one is we need to check the arguments passed to a function using decorators. So what kind of check do you want to do? Say for example, you pass an argument to a function, and that function requires the argument to be a real number all the time, or it requires a floating point number. But say for example the user passes a string which is not valid, okay, or if you want a real number which must be between which cannot be a floating point number, you want that to happen, then if it passes a string, it would still call the function, right? Because your function requires only one parameter and you pass the string. Oh, so it went into the function, but it's going to throw you an error later. But what if, and the error that it would throw would be something which the user may not understand very clearly, but we need to have a decorator which would not call the function at all in the first place if your argument itself was wrong. Hence, we need to check the argument that was passed to a function using decorators. So let's do this particular use case, and let's define a particular method. Let's call it as def argument test. Now we're going to do it for a natural number. Let's test whether the argument is a natural number before passing it to a function. Now the function that we can use for natural number, let's use the function which is factorial. Now factorial, you can just call the factorial of a number, that is the factorial can be just it can take only real or natural numbers 0, 1, 2, 3 and so on. So by the way, how do we calculate a factorial? We can define a particular function. So this function, I'll just leave it for now. I'm not going to go into the function as of now. Let's define the factorial function and then define the decorator for it. So let's say your factorial which calculates the factorial of n. How does it calculate that? It will say if n is equal to 0, what should it do? It should return 0. If n equal to 1, it should return 1. By the way, if n is equal to 0, factorial of 0, is it 0? No, it's 1. I'm sorry. And if it is 1, it should return 1. Else, what should it return? It should return the factorial of n minus 1 multiplied by n. So that's what it should return. So let's say return n multiplied by factorial of n minus 1. So that's a recursive function which keeps calling it again and again. So this is a factorial, but this n that is required out here should be a natural number. And because that should be a natural number, we need to call a decorator which will test the argument before passing it to the factorial function. Alright? Let's say for example over here, I'm going to call the decorator. I'm going to decorate the factorial function with the argument test underscore natural underscore number. So let's now define the decorator out here. Now the decorator needs to be defined. Let's make a helper function which will help us out. The helper which is taking x, and in this I need to say if. So I need to test whether it's a natural number. How will I test that? If type of x is equal to an integer. So the type of x must be an int. And can a factorial be less than 0? Can it be a negative number? No, it cannot be a negative number. Which means if I say and x greater than 0, what should happen? Then you return, call the function that you just passed. What is the function? That function is stored in the object f, which means you're going to return f of x. Okay, once you return f of x, that's only if your type of x is int and if x is greater than 0. But else, what should you do? If it is not an integer and if x is not greater than 0, you need to raise an exception. So let's say we raise exception. We raise an exception, and the exception is going to be, we can define it in our own words, that argument is not an integer. And then once this is done, the argument test natural number function should return helper. That's what we learned about a decorator. Right? With this, let's go ahead and call the factorial function. Okay. Now, how do I call the factorial function? I just need to, let's say, the factorial of a particular number, maybe 5, 6 or something. Let me say I want to have factorial of 10 numbers from 1 to 10. So let me say for I in range, okay, in range 1 to 10. By the way, if this was even greater than equal to 0, that was also fine for me, right? So that's fine. Else, so for I in range, let's go up till 10. That means 0 to 10. And let me print the I, and let me print the factorial of I. I'll print the I and the factorial of I. Okay. With that, we are done with this. Cool. If you want, we can just check if a factorial of -1 can be printed, or factorial of -1 can be printed, or we can print a factorial of 2.3. What is the error that it will give? We can just check. Right? We save that. Let me save it as a use case for decorator. Save it, run it. Okay. So in the first, it just printed for the factorial of 0 is 1, the factorial of 1 is 1, 2 is 2, 3 is 6, 4 is 24, that is 4 into 3, 2 into 1, 5 is again the same. Yeah, but factorial of -1, or what did it raise an exception? Argument is not an integer. Once it raised an exception for that particular number, it just stopped, it didn't go ahead. Right? So a decorator can be used for checking whether an argument is a natural number before passing to the function. So we can test an argument. This is one of the use cases. We'll go to another use case in the next video.